Alright, so this is the variables. The first section is all the references to the player, controller, the camera transform, and the animator for the arm. And next is a reference for the audio source, which is attached to the character, and then an array of sounds which are played when stuff happens. The next is for the mouse movement. Here we have the mouse sensitivity, which you can change, as well as setting it so that the mouse is locked when the game starts, just so that you don't have the mouse moving around when you start the game. This boolean can look, that's set to true or false, and it lets the character look around based on that, which is used for certain movement stuff. Next we have gravity. This is the real world gravity number. Some equation makes this. So basically you can change it yourself. Maybe it'll be better as an even number, but right now it's fine. And then we have the walk speed. I used to have a run, but I got rid of that because it wasn't really needed. This is the jump height. There used to be smooth movement for my character's movement and mouse movement, and this was sort of the, like, how smooth it would be. Here you can see it's got a range, so you can, in the editor, you can change the range for it. Next is the respawn point. There's a public reference for that. So if you fall out of bounds, it respawns you at the respawn point, and that boolean is just to make it so that when you're respawning, nothing else is happening. Next we have the dash. Again, there's another boolean for when you're dashing. There's a dash count, so you can set how many dashes the player has. Current dash count is set to the regular dash count when the game starts, and it's basically just the value that's actually changing. The dash time is a value that you set to put how long the dash will last for, and the dash timer is again the value that actually changes because it's set to the dash time. And the dash distance is how far forward you move by. The grapple is very, very similar. It just has a number of grapples that you can put in. Boolean for if you're grappling or not. The grapple distance, the grapple time, and because the grapple has to use a raycast, it's got a raycast that's publicly available so you can see what's being hit, what's not being hit, and it just records the distance of the raycast. There's also a grapple timer, similar to the dash. There's a stored grapple position, so basically the point that you hit with the raycast, it stores the grapple position there. This next bit is for the thrust pad. It's a separate object, but basically when you walk into the trigger, it moves you by the thrust power. So this has your jump counter, because you have 2 jumps, and your Y velocity is added. So basically the gravity is added to Y velocity pretty much every frame, but if you're on the ground it's set to like a certain number so you're not falling super fast when you fall off a ledge. The cam pitch is just used when calculating mouse movements. The Vector 3 velocity pub is just a public velocity that can be used by other classes, so you can change it using the thrust pad and the jump pad. The last Vector 2 stuff is just your movement inputs and then smoothed. The second ones are the smoothed versions of them, but these aren't used in the final game, or the values are just set to 0. Because they're not being used. In start, the dash timer is set to the dash time, the grapple timer is set to the grapple time, so that when you use them, it does it for the right amount of time. And also, it gets the character controller and sets it to the player character controller. Doing it this way means that you don't have to set it publicly, and if you are setting it public every time, that means you have to drag and drop all of the components every time to reference it. This way it just references itself, you don't need to worry about it, which I haven't done for everything, but I've done for this. And then next it's got the if statement for the lock state. Basically, if lock state set to true, then it just makes the cursor locked when you start the game and invisible. This is the update mouse look function. It's got a vector 2 that stores the mouse X and Y inputs, and then it's got a current mouse delta, which isn't used anymore, really. Well, I mean, it is being used, but it's kind of pointless. and I should probably get rid of it, but I've done it, so here it is. It's got a Vector 2 smooth damp, which it's in a bunch of other stuff like a Vector 2 and a Vector 3, and there's a regular math version of the smooth damp, which just basically all it does is it smooths the movement of an object. In layman's terms, it gets the target mouse delta, which was defined up here, and then smooths it by the mouse smooth time, which is set in the variables. It needs a reference. It needs to store the value somewhere before it can change the actual value. It's a very weird thing. It's not the same. You could have used a alot function, but this is just the way that this one works. And the LUP doesn't have a reference, I don't think. Onto the actual camera stuff. The cam pitch is a value that's minused from the mouse delta y, and then multiplied that by the mouse sensitivity. The reason it's minused is because it works in the opposite direction, so if you plus it, it will invert your movement, but this is only up and down, and it's clamped so that like you can never look behind you only holding up. You can only look behind you if you turn around, because you're not like a ball, if that makes sense. But this is only working on the camera, so this is rotating the camera itself, which is referenced in the variables. So the player cam angle is set to the camera pitch, which is only this camera is only on the x-axis, so it's only going up and down. And then the transform.rotate is used on the actual object itself. So this is the camera, this is not the camera, and not the camera is being rotated by the Y movement. I know it's confusing because it says X and Y and it's kind of the opposite, but it's not the opposite, or it is the opposite. And that's also multiplied by the mouse sense. So the rotation of the transform is set to vector 3.up. The movements don't sound like they match up, but they do. It's vector 3.up multiplied by the user X input and then the mouse sensitivity. This is the dash function. If your character is dashing and the dash timer isn't equal to 0, then it sets your Y velocity to 0, and then sets your current position to transform.forward multiplied by your current direction in the Y, and then adds that to transform.right multiplied by your current direction.x, and then it moves you by your current position by the dash distance. I tried for ages to try and just do this with a transform.direction, and it was just really weird. I don't know why you can't just do that. But I'm assuming the reason is that you need to get your actual direction, you get your forward transform and your right transform. This is the forward axis and this is the right axis, and then you just add these axes together, and your current direction is your current direction, so it's just turning it into your current direction and then setting that to your current position as a vector 3, because these are all vector 3s. And then basically once that is all done, your character moves by your current position multiplied by the dash distance, and then it takes 1 away from the dash timer, and it just repeats this over and over again until dash timer is 0. And when it's 0, it sets dashing to false, and it resets your dash timer to the initial dash time you put in within the variable. This is the grapple function. It's very similar to the dash function in that if you're grappling and the grapple timer isn't 0, then you do a grapple. It sets your can look ability to false, so you can't move the mouse around while you're grappling. It sets your number of grapples to -1, and then it sets your grapple position to the hit point from your raycast minus the transform position. So that the grapple position just gets the direction, really, because you could just use the hit point, but you want the direction. That's the reason I've done that. Your character controller moves by the grapple position multiplied by the grapple distance multiplied by 0.5, and the grapple distance is the variable that you set in the variables, and then you just move in the direction of the grapple position, basically, by the grapple distance. And the reason it's set multiplied by 0.5 is so that you always go half distance no matter how far you go, so you'll never reach your destination, you always go halfway, and that was just a gameplay design choice. And then it just sets the grapple timer to -1 every time it does this loop, and the moment that the grapple timer reaches 0, then it sets all of the stuff back to its default. So velocity y equals 0, grappling equals false, can look equals true, grapple timer equals grapple time. So this is my jump function. It sets your y velocity to -2. It could be 0, but I set it to -2 because it feels a lot better to me. And then it adds this equation, which is pretty much just like the Mario jump. It's used in a lot of games. I did steal this online, don't know if that's illegal, but it's done. And basically, yeah, it's really, this is adding it to -2, so you could just maybe make this equals 2 -2 plus this equation, but it doesn't really matter, it's the same thing. And then it sets the jump counter to -=1, so you're just taking 1 away from the jump counter. So you can do this twice, and that's why it's doing that. This is the update movement function, similar to the update mouse look function in that it takes a vector 2, which just uses your inputs for your left, right, up and down, WASD, and then stores that in the vector 2, and then it normalizes it. A normalize just basically locks it down to like a 1, so that you can't get extra speed when you're going diagonals, which was a problem in like really old games like Quake. This is the smoothing stuff again, so I'm not going to go through that again. If you use the fire button, which is your left click, it plays a sound, casts a ray cast, and then if it hits something with a tag that has grapple on it, it means you can grapple to it, and that's set in the editor. And basically when that happens, it sets your jump counter to 1, your dash counter to 1, and it sets your grappling to true. And then later on, you'll see down here, if you're grappling, then grapple and play the grapple animation, and if you're not grappling, then set grappling to false. Again, do that with the animator. Over here we've got the jump, so if you press the jump button, which is usually space, and the jump counter isn't 0, play the jump sound and execute the jump function. If you've got fire 2 down, which is the dashing button, right click, and you're not dashing and the dash count is greater than 0, then set to dashing. Play the dashing sound, dash, a lot of dashing. Take away 1 from the dash count and set the animations to dashing, otherwise stop the dashing in the animations. Yeah, again, this is the grappling. If you're grappling, then grapple, otherwise don't grapple. If you're dashing, then dash, otherwise don't worry. And basically, if you're not dashing or grappling, then it gives you normal movement, but if you are dashing and grappling, then it doesn't do any of this. So what is this doing? This is setting your gravity multiplied by time delta time, and it's setting that to your velocity y so that you're always falling. And then in velocity pub, this variable, so anyone can see your velocity and alter it, because this is a public variable that I've set in the variables, and it gets your direction, multiplies it by the walk speed, and then adds the gravity multiplied by a vector 3.up, so basically just applying force down. It moves your character by the velocity pub, which I've just done, multiplied by thrust power, multiplied by time.delta time. That thrust power is always going to be 1 unless you're thrusting. The thrust power is only there so that when you jump on a thrust pad, it thrusts you forwards. This is the update function. If you are respawning, then it sets all your movement to false, and it sets respawn to false. If you're not respawning, then it updates the movement. If character controller is grounded, then it sets the animation of being in the air to false, and if you can look, then you can update the mouse movement. And these are things that are just changed if I want to disable the movement or if I want the player to not be able to move. This is in the late update, and it just checks if your character is grounded. If they're grounded, it sets your Y velocity to -2f, so that when you fall off a ledge, it resets your Y velocity so that you don't fall really fast straight away, because otherwise it just keeps counting all the way down even though you are on the ground. And it also sets your jump counter to 2, your number of grapples to 1, your dash count to the initial dash count, and it sets the in air to false. If you're in the air though, it sets it to true. The hand is something I made in Blender with a really basic rig and a bunch of animations, and the animator section in Unity is quite messy, but it gets the job done. It's just got 3 different variables, all 3 booleans, and it just checks them in my character script, and when those are true or false, it affects the character's animation based on those things. So my game has a game manager which manages the HUD stuff. My HUD is just a bunch of images that's just set up on the screen, and the game manager has a bunch of references to them, as well as the controller script for my player, so we can get the variables from that. And basically every update, it updates the jump HUD and updates the buttons, and if you press the escape key, it quits the application, but that's only used when you actually build the game. So the first function, update jump HUD, if the jump count is 2, then it makes the progress bar texture into the full one. If it's 1, it does a half bar, and if it's got any other number, then it sets it to no bar. The update buttons function is only for the other 2 HUD elements, so dash and the grapple. So if you can grapple or dash, it sets it to the can button, and if you can't dash or grapple, it sets it to the can't button. Each jump pad has a jump height, which is set in the editor, and a reference to the player, so that when the player goes within the trigger volume, and it realizes it's a player, then it sets the Y velocity of the player to the jump height. The actual jump pad is just a trigger volume with some fake geometry around it that can't be interacted with, and it's something that I made in Blender in like 10 minutes. This is the thrust pad script. It's got a bunch of variables. It's got the thrust power and the thrust time. It's got a boolean for thrusting, as well as a float for the thrust timer. It's got references to the controller, the player, and the character controller. Honestly, they could all be under the same thing. I think I was just sort of in a rush when I made this. But in the start function, it sets the thrust timer to thrust time. And on the update function, if you're thrusting, it calls the thrust function. And in the thrust function, if the thrust timer is greater than 0, then it moves the character forwards and minuses 1 from the thrust timer. And then if it's 0, then it sets thrust timer to thrust time, sets the character velocity to 10, so it makes them jump. It gives them a small jump boost when they finish their thrusting, and then it sets thrusting to false. And on the trigger enter, it sets thrusting to true. It also has a panning script, which basically just scrolls the Y offset of the material, and that's used on the middle of the asset basically. So it looks like a conveyor belt that's going quite fast, and every second it moves the Y based on the Y given in scroll Y. I used package assets for the Starfield skybox. The floor I made myself. The texture for it I got online. It's just a generic checkerboard texture, which I've used in a lot of the assets. But everything I have made myself apart from that, I think.